All right, so let's continue our lecture on choosing the correct statistical test. So I've just given you a quick high-level overview of the different types of the flow. We've gone through some flow charts and different types of data that you may have in different types of statistical tests, depending on what you have. So if you have I refer to the term parametric. Parametric tests are used for interval or ratio level data. So where you have numerical scales and the data is normally distributed. And the samples typically will have similar variance. And the observations in a group are independent. Non-parametric tests are nominal or ordinal data, or when you cannot meet the assumptions of a parametric test. It's always appropriate to choose a non-parametric test. Non-parametric tests tend to be a little bit more conservative in their p-values in terms of finding significance. And these non-parametric tests are considered distribution-free, and they're especially useful when you have small sample sizes. All right, so some non-parametric tests that we've talked about is first one would be a chi-square test. And this is where you're evaluating the difference between observed and expected outcomes. You're testing an association between two discrete or say nominal level variables. You can also even do this with ordinal level data that you treat as discrete. Now if you have a smaller sample size, you can use an alternative as what's called a Fisher's exact test. And a McNemar's test is when you have paired nominal data. And this is common in studies that have before and after designs. If your goal is to look at relationships, this may be leading you to look at correlation coefficients. And this is testing whether there is a relationship or an association between two variables. Now you would choose a Pearson R, or Pearson correlation coefficient, if you have a dependent and independent variable are both on a continuous level data. A Spearman-Rho is a non-parametric version of this test when you have ordinal level data. If your goal is to make predictions, you can, if you have one independent variable, which sometimes we will refer to as a predictor, or which is measured on the x-axis, to predict a dependent variable or an outcome variable, which would be measured on the y-axis. Multiple linear regression is where you're looking at the effects of two or more independent variables or predictors on a dependent measure. And logistic regression is when you have two or more independent variables and you're trying to predict some binary outcome. Maybe we're trying to predict postoperative nausea and vomiting. So here's some example of some non-parametric tests. A Mann-Whitney U is a non-parametric test where you're comparing two groups that have ordinal data and you're looking at differences between the groups. Maybe you're looking at differences between the median pain scores. A Kruskal-Wallis test is a non-parametric test. And it's similar to what we would call an analysis of variance, but you're using ordinal level data. And basically, this is used when you have three or more groups instead of using a Mann-Whitney U. A Wilcoxon rank sum test is a non-parametric test for when you're comparing two paired groups that have ordinal level data. And a Friedman's test is when it's an alternative to what we call an ANOVA, where you have multiple groups or you have repeated measurements. It's used to test differences between groups when the dependent variable is also ordinal. Now, if we get into parametric tests, the most common one that we know of is when we're looking at, let's say, mean differences in pain scores. That would be with a t-test where both groups are also independent. So you have a treatment and a control group. A pair t-test is maybe when you're doing a pre-post measurement, and you're testing differences between the two groups of dependent groups. An analysis of variance is this is where you're testing differences among two or more independent groups or more than one independent variable. And these types of analyses can get rather complicated. And then there's also what's referred to as an analysis of covariance. Remember earlier we talked about confounding variables. So sometimes we just, for whatever reason, we cannot control for some confounding variable. Maybe we're unable to randomize, and we have maybe more of an observational study. And what this does is it tests for differences between group means after adjusting for the scores on the dependent variable, and it helps eliminate the effects of some covariant or confounding variable. Kaplan-Meier curves. I believe we're going to have a lecture later in the course that will talk about time to event analysis. And this is the probability of maybe surviving or probability of some event occurring, like say survival or not surviving. But it's not necessarily life or death, but sometimes it's time to some event occurring or not occurring. And then factor analysis is a lot of times used in instrument development, is where we're trying to take a large set of variables to a more manageable set of measures. Well, I hope that this was a nice review for you. If you have any questions, feel free to contact us. Thank you.